So, what we're going to be talking about today is inequalities. Everything that we've been talking about so far, we talked about expressions where we would have something like 3x plus 3, and it's called an expression because it's just what it is, right? It's not equal to anything, it's not unequal to anything. And then we started dealing with equalities. And anytime you have an equality, it means that we have something that is set equal to something else, right? And we could then solve for whatever our variable is, our missing piece. Today, what we're going to be talking about, though, is inequalities. And you guys have probably seen them before years ago, but they deal with things like greater than, less than, or greater than and equal to, and less than and equal to. And the difference, really, the main difference between an equality and an inequality is your solutions are sets of numbers when we're talking about inequalities, right? So if I have something like x is greater than 3, right? X can be anything that's bigger than 3. If we were checking that out on a number line, boom, we would have, like, say 3 here, and x would be everything bigger than that. It would probably be better if I did that in a different color so you could see it, right? X would be greater than, it doesn't include 3, but it contains everything that is bigger than 3, right? If I was writing that in what we'd call interval notation, which you wouldn't be using, right? We're just saying x is greater than 3 is. It's 3 all the way to infinity, right? So it is a set of numbers that make this true. It's everything that makes this a true statement. So 4 is greater than 3, 5, 6, 7, 8, 18 million. All those things are greater than 3. So all of those are part of our solution set, right? Couple of rules when we're talking about inequalities. Anytime we're dealing with inequalities, we kind of have to graph them. Sort of like the rule of inequalities. So we're going to start with, let's look at rules. Rules for inequalities. Rule number one. If you're graphing, you want to use an open circle, an open dot for greater than or less than, right? So if I have, like in this case, we had x is greater than 3. When we graphed it, right, at 3, we used an open dot to start with. The idea behind that is when something is greater than 3, it doesn't actually include 3, right? It starts at 3, but it's all the things that are bigger than 3. So ultimately, we keep that open dot to show that it's not actually including 3. We use a closed dot for greater than and equal to or less than and equal to. And that's what that little line underneath means. It means, yes, it can be greater than, but it can also be equal to. So if I were to graph x is greater than or equal to 3, when I drew that graph and I had my point here at 3, when I graphed it, I would have a closed dot and it would be everything greater than 3. And it just indicates that we're also including the 3. Often you'll see it as, you can use parentheses for greater than or less than, right? So same thing, if I have x is greater than 3, I could have my 3 here and I could use an open parentheses like that to indicate it. Where if it was x is greater than or equal to, and I had my 3, I could use a bracket to indicate the equal to. I personally prefer the open or closed dot. I think it's just a little easier to see and understand, but you get the general gist of things. So let's look at a few problems and graph those. If I have, for example, x is greater than -1, and I needed to graph that, I would start at -1, right? Wherever that was on the graph. And I'd go, it's greater than, but it isn't equal to. So I have an open dot and it's going to cover everything in that direction, right? If I have x is less than or equal to -5, I'm going to make my number line and I'm going to go, okay, well, here's -5. And we know that it is less than or equal to -5. So we're going to have a solid dot because it can equal -5. And it's going to take me in that direction. So nothing too extravagant. Sometimes you'll just get the graph though, and you will have to come up with the inequality by yourself. So say I'm given a graph where I have something like this, and there'd usually be a whole lot of numbers on that graph, but say I have 0 right here, and on it I have a closed dot going in this direction, right? Well, we could say that x is less than or equal to, right? Because it's going in the area of less than, right? This is our minus, this is our plus, and we're going towards the minus. So it is less than or equal to 0, right? If we did it with, say, we were at -3 and we had an open dot going in this direction, we would say that x is, now we're getting on the bigger side, right? The numbers are going to get bigger in this direction and smaller in that direction. So if x is greater than, but it's an open dot, so not equal to -3. So pay particular attention to that. Otherwise, pretty much when we're solving inequalities, like that was for graphing them. When we go to solve inequalities, they solve just like any other problem, except for you're getting a set for answers instead of a specific number. But we have one other rule that, you'll probably forget from time to time because everyone does. But that is that you must flip the sign when you multiply or divide by a negative number. Keep that in mind. Why am I saying to keep that in mind? Because it will probably be one of your questions at the end of this ed puzzle. I'll be like, what do you need to do when you multiply by a negative, multiply or divide by a negative number? And you'll have to say flip the sign. Or I'll say, hey, when is it that you need to flip the sign? And you're going to say, hey, when you multiply or divide by a negative number, right? Every time you do it, you'll have to flip the sign. That is the only thing that's different when you're solving for an inequality, that is different from solving from an equation. So let's look at a couple of these examples that I have here. If I have 3x plus 2 is less than negative 4, right? The whole idea, just like with an equation, just like when we're dealing with an equation, is we want to get that x all by itself. And so we're going to start undoing all the things that have been done to it. And we're going to do it in that same backwards order that we did before. So I'm going to start by subtracting 2 from both sides, and I get 3x is less than negative 6, right? And the only thing left on that x now is the 3 that's multiplied to it. So I'm going to divide by 3, and I'm going to have x is less than negative 2. That is my solution. That's all the solution I need. Once I know what x is less than or greater than, I get to be done, right? Because I've isolated that x. If I want to graph that problem, and I do, yes, I do, right? I would make a graph and I'd have a point at negative 2. It would be an open dot point, right? Because we're not equal to, we're just less than. And it would be everything less than negative 2. Let's try something a little bit more difficult. So if I have x over 6 plus 2 is greater than negative 1. Don't panic at this fraction. It's not as hard to deal with as you might think. Let's start by getting rid of this 2, right? Because the whole idea, again, is to get x by itself. So I'm going to undo everything being done to it. Here I have 2 being added to it, so I'm going to subtract 2. Once I do it to one side, I also have to do it to the other side to maintain the values. And so here I'm going to be left with x over 6 is greater than negative 3, right? Negative 3. Just need to learn how to write. So this looks good, except for now I have this fraction. And I need to get this x by itself, but it's got that denominator of 6. Well, if I want to get rid of anything in a denominator, if I want to clear a fraction, I just multiply by whatever that denominator is. But I have to do it to both sides for the same reason, right? We need to maintain what we're doing. We don't want to change the value of anything. We're just changing the position. So these 6's cancel, and I'm left with x is greater than negative 18. Now keep in mind, I did not multiply or divide by a negative number. So this is a perfectly sufficient answer, right? I didn't have to change any sign because I added 6, right? But that negative was already there. I didn't, I added this negative 2, but I didn't multiply or divide by it. And so I did not have to change the sign. And so now I can go ahead and I can graph this. I go, okay, well, this is negative 18. We know that it is just greater than, it is not greater than or equal to, so it is an open dot, and it covers everything in that direction. I'm hoping I have a few harder ones here for you. Oh, good, I do. I have lots of them. But none of them get all that difficult. We're not moving into anything too difficult. Like these simple fractions are about as tough as it gets, but like I don't have anything set aside that's super tough for you. if I have negative 2x minus 5 is less than or equal to 19, I want to solve that for x, and then I want to graph that solution set. So I'm going to start by adding 5 to both sides, and I get negative 2x is less than or equal to 24. And now I have the only thing left on that x is the negative 2. So I'm going to divide that by negative 2, and I'm going to divide this by negative 2. So don't forget, this is where we're going to need to use our rule, right? Our flip rule, right? We are dividing by a negative number, which means that we are going to have to flip the sign, and we're going to be left with x is now greater than or equal to 24 divided by 2, which is negative 12, right? And so we're saying when we graph this that at negative 12, we're going to have a point, right? It's going to be a solid dot point, and it is going to be everything bigger than negative 12, right? That is our solution set. Trying to find you something more difficult than that. Let's try one more that has a fraction. We'll see how it goes. But I don't have any that are super difficult for you, and that should come, I would think, as a relief to you, because, that means you're not going to get a ton of really difficult problems on your homework, right? So if I have x plus 11 over negative, that problem didn't even like itself, over negative 2, less than negative 2. The first thing that we're going to do is we are going to clear that denominator, right? Remember when I said if we have a denominator, we've got to start undoing that stuff. And if we want to clear a denominator, all we have to do is multiply everything by that denominator. So I'm going to multiply this times negative 2 and this times negative 2. Now, keep in mind, I am multiplying times a negative number, which means that we are going to have to use the flip rule, right? So the sign is going to flip on us here. These will cancel, and I'll be left with x plus 11 greater than 4, right? And now we're just going to finish off by subtracting the 11 off of both sides. But now we're subtracting. We're not multiplying or dividing, so we don't change the sign again. Equals 4 minus 11, which is negative 7. And if I wanted to graph that, I would have my negative 7 here. And then I'd go, okay, open dot, because it is greater than, but does not include. That's about as difficult as it's going to get. I'm not taking it any further from you than that. You'll have one question to answer here at the end of this ed puzzle, which I already kind of hinted to you about what it was going to be. So if you're paying attention to that, you took a note. Beyond that, you will have an assignment in Delta Math, and that will be it for this week. So make sure and get that done. If you need any help, let me know, and I am happy to jump into a Google Meet with you or respond via email, whatever you need. Just let me know. I hope you have a good week, and I will talk to y'all soon.